हेलो एंड वेलकम बैक। इस लेक्चर में हम लोग कुछ क्वेश्चन डिस्कस करेंगे बेस्ड ऑन इक्वेशन ऑफ कंटिन्यूटी। ऑल ऑफ अस हैज़ एक्सपीरियंस दिस एज अ चाइल्ड कि अगर एक गार्डन होज है तो उसमें तुम वाटर फ्लो के स्पीड को बढ़ा सकते हो बाय कवरिंग अ पोर्शन ऑफ दैट पाइप विथ योर थंब। सो ये एक प्रैक्टिकल एग्जाम्पल है इक्वेशन ऑफ कंटिन्यूटी का। मैथमेटिकली we write dm by dt equal to rho av, also known as mass flow rate, or av equal to constant incompressible flow या ideal flow के लिए what we say av is constant, and that is your equation of continuity. This av is also known as volume flow rate और उसको capital Q से भी denote करते हैं. So let us consider few numericals based on this concept. First question: water flows continuously in and out of an arrangement of pipes as shown in figure. What is the flow rate from pipe A? Is the water flowing into or out of this pipe? Let us use equation of continuity to prove this, and we will use the fact that water entering and water exiting this pipe must equal each other. So suppose, let us first write water that is entering. So for entering, flow rates are 20 centimeter cube per second and 10. At A, let us assume that water leaves. Now this must equal water that is exiting. 10 centimeter cube per second plus 5 plus, suppose flow rate at A, let us write that as A, plus 8 plus 2. Now this 10 will cancel out. 5 plus 8 plus 2 is 15. So 20 is equal to 15 plus A. So A is equal to 5 centimeter cube per second. So this will be flow rate at A, and water is flowing out. Next question. Water flows in a pipe from a large cross-sectional area A1 with a speed V1 to a smaller cross-sectional area A2. What is speed V2 at which water leaves the smaller cross-section, as in the left part of figure? So in this part, so let us use for part A equation of continuity. A1 V1 is equal to A2 V2. So V2 is equal to A1 by A2 into V1. Substitute numerical values. A1 is 0.5 meter square, A2 is 0.05 meter square, and V1 is 15 meter per second. So this comes out to be 150 meter per second. Part B, what is effect of lowering A2 by 10 meter as in the right part of figure? So in this part, if you lower this narrow part by 10 meter, then what will be the effect? Now, since equation of continuity does not depend on altitude, so the lowering of narrower part by 10 meter will not cause any change in the previous result. So V2 will remain 150 meter per second. Next question. A fluid flows in a cylindrical pipe of radius R1 with speed V1. What would be speed of this fluid at a point where the fluid is confined to a cylindrical part of radius R2, which is equal to R1 by 5? See the top part of figure. So for this figure, how much is V2? R2 is given as R1 by 5. So we will use equation of continuity. A1 V1 is equal to A2 V2. So V2 is equal to A1 by A2 into V1. A1 is pi R1 square, A2 is pi R2 square into V1. Pi will cancel out. This is equal to R1 square by R2 is R1 by 5. So R1 square by 5 square, that is into 25 V1. So V2 is equal to 25 V1. And as far as part B is concerned, for part B, what is effect of elevating the constriction in pi by h equal to 10 meters? So see the lower part of figure. So in this part, so as discussed in previous case, this change of altitude is not going to alter equation of continuity. So this equation remains same. As a result, V2 remains 25 V1. So this is an important concept, that equation of continuity does not change with altitude. A1 V1 or A into V is a constant irrespective of what is the altitude or what is the depth or what may be the height. Question: water flowing from a faucet of cross-sectional area A equal to 2 centimeters square is used to fill a bucket of volume 30 liters equal to 30 into 10 power 3 centimeter cube. What is speed V at which the water leaves the faucet if it takes exactly 1 minute to fill the bucket? So flow rate or volume flow rate which we also denote with symbol Q is 30 liters per minute equal to 30 into 10 to the power 3 by 60 centimeter cube per second. So this is equal to 500 centimeter cube per second. As volume rate is equal to A into V, so now we can find V because area of cross section is given. So Q is 500 centimeter cube per second and area is 2 centimeter square. So this is equal to 250 centimeter per second or 2.50 meter per second.